Peace be upon you and God's mercy and blessings. Let's now take a look together at the circuit breaker timing test. I am measuring 4 timings for the circuit breaker. The first timing I have is the closing time, which is the time calculated from the moment the close command is issued to the circuit breaker, meaning when voltage is applied to the closing coil of the circuit breaker, until the main poles of the circuit breaker close, not the auxiliary contacts of the circuit breaker. I am talking here about the main poles of the circuit breaker closing. I will conduct this experiment at 3 different control levels. The first level is 100% of the control levels, and the initial control levels are 125 DC. Then, I will perform different levels of control, and the initial control levels are 100% of the control levels. And 110% because I want to ensure the accuracy of the test. The circuit breaker, if I close it and have under voltage in my control voltage or have over voltage in my control voltage, well, the typical closing time will be approximately less than or equal to 60 minutes. And this is usually the case in medium voltage circuit breakers. However, in high voltage circuit breakers, it is less than or equal to 110 milliseconds. Circuit breakers are less than or equal to 110 milliseconds. After that, there is something called the difference between phases, which refers to pole discrepancy. This means pole discrepancy in the case of a 3-pole circuit breaker, meaning 3 poles are moved by only one mechanism inside the circuit breaker. We are not talking about circuit breakers that use extra high voltage, where each phase has its own standalone circuit breaker with its own mechanism. No, here I am talking about a 3-pole circuit breaker that moves with one mechanism. Here, the difference between phases or the pole discrepancy does not exceed 2 milliseconds, and in some cases up to 4 milliseconds. This data is available to you in the FAT test. The second time we have is the opening time, which is the time from the moment an open command is given to the circuit breaker, meaning when voltage is applied to the trip coil of the circuit breaker until the main poles of the circuit breaker open again. This test is also conducted at 3 different levels of control voltage at 100% of the rated voltage, which is 125 volts DC. Voltage at 100% of what, and at under and over voltage, 70% and 110% of the rate of voltage. Here I want to see the behavior of the circuit breaker if I gave it an open command and I had under and over voltage in the control voltage that I'm applying to the trip coil of the circuit breaker. The typical time or typical opening time will be less than or equal to 40 milliseconds. And this is most of the cases in the medium and even in the high voltage circuit breakers. The control voltage that I applied to the trip coil of the circuit breaker, the typical time or typical opening time is usually less than or equal to 40 milliseconds. And this is the case in most situations for medium voltage circuit breakers. And you have a volt discrepancy in the opening process, which is also about less than or equal to 2 or 4 milliseconds. The third time I have is the close open time. Through the close open time, I can determine the response of the circuit breaker under certain conditions, like switching into fault. I want to see the response of the circuit breaker in the case where I give it a close command, the breaker closes, and there is a fault existing on my line. The last time I have is the open close open, through which I can determine the response of the circuit breaker under certain conditions, like auto reclosure. I want to see the response of the circuit breaker if the breaker trips due to, for example, a fault on the line, and then the auto reclosure function activates and gives an auto close command to the circuit breaker while the fault still exists on my line. Thank you for watching.